Okay, here we go. We are going to discuss powers and roots of complex numbers. The last time we're taking notes this semester.
Woohoo! I finished. I think we should have a party.
Okay. Okay, so you're gonna help me out a little bit here.
Okay.
Here's my complex number. Okay, very basic, right? I would like you to find, okay, it equals z. I want you to find z squared, z cubed, and z to the fourth. Now, before you get all worried here, okay, something squared, what does that mean? Multiplied by itself. Okay, so to find z squared, just take this times itself and follow that pattern. Just see what you find. Not theta squared. What do you do with the r's? What do you do with the thetas? Here, you don't multiply these. What do you do when you multiply? We multiply the r's and we add the thetas. Yes. I say that.
Wrong.
You don't add the cosine, that's you have cosine of.
Yeah, she just said. What's recording the audio? Is it like the smart board or what's
My computer.
like face the computer towards you?
Well, it's right here.
Hey.
Okay. Jackson. What happens when we take z times z?
You get R.
Oh, that's some
Times cosine 2 theta plus I sine 2 theta.
Okay? We multiply the r's to get r times r. We add the thetas to get theta plus theta. And so our angle is 2 theta, and our r becomes r squared. Okay? What happens when we multiply by z again?
R cubed 3 theta.
And what happens with z to the fourth?
R to the fourth cosine of 4 theta plus I sine of
Do you see a pattern?
Definitely.
No? Okay.
It's all the same number.
Whatever power we're being raised to. R gets raised to that power, and theta gets multiplied to that power. So here you go. Anybody in front? How do you say it? Demois. Demois theorem. Okay? If we have a complex number raised to a power, we take the r to that power, and we take theta multiplied to that power. Once again, if you're leaving it in trig form, we need to be between 0 and 360 degrees, or 0 and 2 pi radians. So you're going to have to use coterminal angles here. Okay? This number, this angle could get pretty big, so you might have to subtract 360 a few times. You ready? Okay.
Well,
Does anybody want to multiply this binomial 12 times?
yes.
No, you'd actually be doing 11 multiplications, but seriously, you wouldn't do that.
Yeah.
No. So what we can do is we can put this in trig form and use the Moise theorem to help us. Okay? So, what quadrant are we in?
Second.
Okay. So this is R, and here is theta prime. What is R? Okay. Theta. Let's take. Okay. Radical 3 over 1, right? Our reference angle is what? 60 degrees. Since we are in the second quadrant, our angle is. Yay. Good job. Okay. So what we have is 2. I'm going to factor the R out 2 times the cosine of 120 plus I times the sine of 120. Okay. And all of that is being raised to the 12th power. All right, help me out. What is 2 to the 12th power?
4,096.
Times, what do we do with the angles? Multiply 12. So 1,440. Okay. Now your job is to find me the coterminal angle that is between 0 and positive 360. What? 0. Who agrees with Maggie?
Oh, 0,
Yeah? Okay. What is the cosine of 0 degrees? Well, I guess first of all, hold on. This is in trig form. Our problem started out in standard form, so we should answer it in standard form. Okay? So, let's convert this. What is the cosine of 0? 1. So, 4096 times 1. What's the sine of 0? 0. So we actually don't have an imaginary piece to this complex number. Is this better? That's the number. That is the number that you get when you take negative 1 plus square root of 3I to the 12th power. Yeah. Graphically, on the complex plane, we would just go horizontally in the positive direction 496 units. Okay? Yes. We got 0. Are you okay with 1,440 degrees? Okay, well, we needed the coterminal angle that's between 0 and 360. So you have to subtract 360 degrees until you are somewhere in that first rotation.
So wouldn't you?
If you keep subtracting 360, you get to 0.
So does it have to be less than 360 degrees then? Since we didn't just
Well, if you already did 360,
it's the same thing.
Your angle needs to be between 0 and 360. So yes, less than 360, greater than or equal to 0. Okay? Yes. Okay. We're good. We're doing okay.
Could you like take the cosine of 1,440 and then based on that, like find the angle off of that? Just quicker.
Well, I mean, technically, yes, you could put this in your calculator right now. Right.
If you want.
Right. Right. And if you are going from trig form to standard form, it's really not a big deal if your angle isn't in between 0 and 360. But if you're going to leave it in trig form, it needs to be. So I just did this extra step to help you remember that. Okay. Does everyone understand that? Okay. All right. So here we go. Nth roots of a complex number. This is supposed to be distinct. District distinct. Okay, so for a positive integer n, the complex number, okay, basic complex number, has exactly n distinct nth roots given by this. So just write down the formula right now. Okay. So what this is finding is you can take a complex number, okay? If I ask you for the fifth roots, that means we are finding all the numbers that when we take the fifth power, we get whatever number we started with, right? Okay. So what you are going to do, you are going to take, first of all, the nth root of r. Okay, that's pretty basic, right? Here, you are going to take your original angle and you're going to add 2 pi k or 360 degrees k, depends on if you're in degrees or radians, okay, divided by n. Now, k is 0 all the way up for 1 less than what your n is. So if I ask you for the sixth root, you're going to do this 6 different times. When k is 0, 1, 2, 3, 4, and 5. Okay. What? No. No. Okay, so here we go. I want the square root of 16 times the cosine of 60 degrees plus I sine of 60 degrees. We're looking for the square root. How many are we going to find? 2.
2. Oh.
Okay, we are going to find them when k is 0 and when k is 1. What? Right. since we're finding the square root, n is 2. All right?
What is the
Correct. Well, when you raise something to the 0 power, it's 1, so you don't know.
So it means it's zero. Oh, then that looks.
You can't raise something to the 0. Here we go. So for when k equals 0, we have the square root of 16 times the cosine. We are going to take 60 degrees plus, since we're in degrees, we're going to think of this as 360. Okay? Now this is 360 times k, which is 0. And then we're going to divide that by n. So what's our angle really? Okay. Square root of 16 is 4. We're not solving. Okay. Cosine of 30. Sine of 30. All right. So our one of our square roots is going to be 2 radical 3 plus 2i. If I square this number, I will get back to z. Okay. Yes.
So does it matter that we start with
For these problems, I will probably have you keep them in standard form. Okay. Okay? Okay. When k is 1, we have the square root of 16 still. But now we have the cosine of 60 degrees plus 360 times 1. Okay, now sine has the exact same angle, so let's just save us some pencil lead. What is 60 plus 360 divided by 2? Okay. So square root of 16 is 4. What is the cosine of 210? And what is the sine of 210? Negative 1/2, correct? Right, because we're in the third quadrant. So we have negative 2 radical 3 minus 2i. Both of these numbers, if we square them, we get back to our original z. What? I don't know if that'll happen every time. I don't think it will happen every time. Because if we did like the third root,
But between 0 and 1, we're rotating 390 degrees.
right, which that happens since we had two of them. You see that rotation of 180 degrees. Okay, if we had three of them, it's not going to be 180 degrees. You see what I'm saying? Okay. So this kind of was a special case where you saw that happen, but it's not going to be both positive, both negative every time. Okay. We're finding the sixth roots of 1.
Just 1.
There's 6 of them. No. Okay, first of all, let's put this in trig form. What is our angle? 0 degrees. And what's our absolute value? What's R? 1. Okay. So 1 is the same thing as 1 times the cosine of 0 plus I sine of 0. Right? If I'm finding the sixth roots, then I'm finding when k is 0, 1, 2, 3, 4, and 5. Are you ready? What? We'll talk about that in a little bit. Okay, so we have the sixth root of 1 times the cosine of, we're going to take 0 degrees and we're going to add 360 times 0 divided by 2. So our angle is still 0, isn't it? Oh, divided by 6. Thank you. Okay. So we have the cosine of 0 and the sine of 0. So our first sixth root is just 1. Which you guys all knew that was going to happen, right? We were going to have 1 to the 6th power is 1. Okay. When k is 1, we have 0 plus 360 times 1 divided by 6 for our angle. What is that angle? 60 degrees. Okay. So the sixth root of 1 is 1. What's the cosine of 60? And what's the sine of 60? So we have 1/2 plus radical 3 over 2i. Here we go. Sixth root of 1 times the cosine of 0 degrees plus 360 times 2 over 6. So our angle is now 120. Okay. Well, the sixth root of 1 is 1. What's the cosine of 120? Negative 1/2. What's the sine of 120? All right. And k is 3. We have the sixth root of 1 times the cosine of 0 plus 360 times 3 over 6. What angle does that give us?
1,080.
Divided by 6. 180.
What?
So we have 1 times, what's the cosine of 180? What's the sine of 180? Negative 1 to the 6 is 1, right? When k is 4, we have the 6th root of 1 times the cosine of 0 plus 360 times 4 over 6, which means our angle is what?
40.
So what is the cosine?
Negative radical 3 over 2.
Last one, yay!
Whoa! About time. We should not do this many homework. Yeah, I agree.
On your test, it's going to be the 12th root.
Why would you tell us
I'm kidding.
I would not do that. That's so, that would take us forever.
Okay, what's our angle when k is 5?
You guys have got
Okay, our angle when k is 5 is 300, so we have 1/2 minus radical 3 over 2i. Chase, what's the pattern? Okay, did you see what happened with our angles? They went by 60 degrees, didn't they? These are all evenly spaced apart on the complex plane. Okay. How do you why do you think it's 60 degrees that these were all spaced?
Oh.
Because it's 360 divided by 6. How far apart were my second roots? 180. And why do you think that is?
Oh, 360 divided by 2.
360 divided by 2. Okay? So, if you need that shortcut, you may use it. What? Yeah, you can find the first one, and then if you know that it's the 4th root, they're all going to be how many degrees apart? 90 degrees. So find the first angle, and then you can use that pattern from there. Or you can just use this formula and you can plug and chug. That can be your decision.